Hey guys, what is going on? Welcome back to another video here on the channel. In this video, we're going to be taking a look at the RCexplained RC Calc Sheet version 1.010. Thank you to all the patrons of the RCexplained channel. If you don't know about this spreadsheet, all of you have the ability to go onto the Patreon website and download the most recent copy of this spreadsheet. If you're not watching this video in December of 2022, because we come out with a new version every single month with more powerful features expanding this spreadsheet, you will have to find the most recent post with the most recent version available. Let's go through the most recent update that we've done here in December. The December release here has this new gray box that has been added that contains information about the pinion gear as well as the spur gear for the motor to spool or motor to spur gear, as well as the differential specific to that radio controlled vehicle. All these values here are going to be linked to the pinion gear as well as the spur gear here for the motor, as well as this area for the differential on the calculating speed calculator, as well as the selecting the motor KV calculator. So no longer will you have to go and find out what your differential pinion and differential spur gear is for your specific radio control vehicle. Now currently there are only 2 radio control vehicles that are available on this radio controlled calc sheet. However, if you have a suggestion as to which vehicle I should add, I can most definitely add those in to this spreadsheet. Leave a comment on the YouTube video here or message me through the Patreon website. I make sure that I answer every single question from all patrons. So if you have something that you want to ask, make sure you do it there on the website. So let's go through a couple examples so we can understand how exactly this works. So if we're looking at a radio control build, and this is the parameters, we'll go through this and we'll select, let's say it's a 1650 kV motor. One of the biggest things that we have to input here is the max voltage per cell of the battery pack that we're using. Ours is going to be a 4.2 volt as our max, and then way here on the right hand side we're able to calculate the loaded voltage per cell, which is very important for what we need. This is the value that gets used here in blue on column E. If we look at the loaded current at the speed we are trying to achieve, we have to know approximately what kind of current draw should we see. Now, a lot of the Castle ESCs give us this information. If we've ran a car in the past, we're going to know approximately where we are probably going to be. So if we're looking at a complex system such as this one, 8-cell 1650 kV with some aggressive gearing giving us 145 mile per hour potential, we're probably going to be upwards of around the 400 amp, 300 to 400 amp mark when we hit that top speed for this vehicle. The next box that we have to put in here is the average IR per cell. Now typically with radio controlled top speed runs, you're going to want battery packs that have an average below 1 milliohm. These are going to be the good packs. If you have an average or subpar pack, you're probably going to be around 2 milliohms or potentially even higher. For speed runs, I would not recommend going much higher than the 2 milliohm mark. At that point, it's best to probably get a new battery pack. This will help your ESC and reduce the amount of ripple voltage that ESC is going to have to deal with. Now, if you don't know anything about the calculated loaded voltage per cell, all you need to do is go ahead and put in a battery voltage of, let's say, 3.2 under load. Doing that has now overwritten the value here. It is no longer linked to the loaded voltage per cell calculation that's done on the right hand side. You can use this value now as a loaded value to represent your build from here on out. So we'll undo that so that we have the calculated loaded voltage based on parameters that we have entered. And if we're going to use now a Limitless V1, we can now get a top speed of 119 miles per hour with this setup. And now looking at the Limitless V2 here, the smallest pinion gear you can put on that vehicle is a 32 tooth for the motor pinion gear. We're going to get about 145 miles per hour out of this setup. That's going to be pushing this motor pretty significantly, this 1650 kV. Now let's move to another example where if we have the new Castle motor that came out maybe about a year ago, it's a 2400 kV motor and it has the potential to draw a ton of power because it's got a high RPM and it pulls a lot of amps. If we look at what we're dealing with on this motor, we already see a speed of 211 miles per hour using essentially stock gearing and the smallest pinion gear that we can physically get onto this vehicle. This is not something that I would recommend, 211 miles per hour. This is what makes this calculator so powerful, knowing that this is not a good setup and we can change things by altering our gearing. So here we have everything linked to this spreadsheet. However, if we don't want to use these values, all we need to do is enter the value here in that we want to use. Let's say we're going to go down the pinion gear by 5 teeth. We go to a 27 tooth. If we do that, we have to go up by 5 teeth on our spur gear. We go up to a 44 tooth gear, and now we're looking at a more reasonable 157 miles per hour here with our setup. So that's going to be a big difference there, and this is now no longer linked to the gray area. If you do want to get back to that linked values, of course you can Control Z. We can get back to that using the Control Z function, or if you ended up having 27 and 44 left in here, you can also just hit the equal button, make this cell equal to the cell here under pinion and under the motor row. And that will relink it back up to this cell D14. And if you highlight this area, you can see that's highlighted and it's the correct value. So those are a couple different ways how you can get it back. It's the same with the voltage per cell. If you did and end up changing this, you can relink it by just hitting the equals button, clicking the cell that makes the most appropriate sense, and get that value back there in linked fashion. Well guys, that's it for this video. I hope you enjoyed the update video here, and as always, like the video, don't forget to hit that subscribe button, check out the Patreon website in the link below, and I'll see you in the next video. Thanks a lot for watching. See you in the next one.